Lechatliers principle. It's French. Lechatliers. And Lechatliers principle has a reaction. It's talking about reactions with double arrows. Double arrows mean the reaction can go back and forth. You can make it go one way, or you can turn it around and make it go the other way. Now, let me explain to you why we have a chemical reaction here on the side of a bathtub. A bathtub with two faucets and an imaginary divider. Imaginary divider. Okay, wouldn't that be great if you had a bathtub with two faucets? You guys always dreamed about that when you were kids. Okay, why would you have to go all the way over here when you could just get the water from here? That would be cool. This chemical reaction right here, G, means you have nitrogen gas. You have 3 moles of hydrogen gas, and you have a double arrow, meaning it could go to the right and make 2 moles of ammonia gas plus 22 kilocalories of heat, or you could turn it around the other way and you could make nitrogen gas and hydrogen gas again. Lechatliers principle states that when you have chemical reactions that you can go forward and backward with, there are some factors that make it go that way. Okay? Now I'm going to explain Lechatliers principle as if it were operating a bathtub. Everything on this left side of the divider is a reactant over here. Okay? Everything on the right side of the divider is a product. I'm talking about this black line right here being the divider. Alright, let's clear out all this writing. Okay? And let's undo what we just did. There we go. Let's erase. Now, I want you to think about this as a bathtub. When you have Lechatliers principle, when you have a double arrow, you have Lechatliers principle here. I want you to imagine that all the reactants over here are on this left side of the divider, and you can do one of two things. You can either add water on this side of the bathtub, or there's a plug down here. You can pull this plug. Same is true for the other side. Over here you can add water, or let's say there's an imaginary plug on this side too. Whatever you do to the left side will cause a reaction that is opposite. For example, in a bathtub, if you add water, if you open the faucet, the water doesn't just stay on this side. It begins moving over here, fills the bathtub, right? If you drain, if you pull the plug from this side of the bathtub, then all the water that's in the bathtub drains out. It drains out. Now, on the other side, if you turn this faucet on, the water doesn't just stay here. It moves over here. If you have an imaginary plug and you pull the plug on this side, the water's going to all rush out. So how does this apply to chemistry? Well, whatever you do to one side, it's going to react opposite. If you add more nitrogen into this reaction, it's going to be the same concept as if you turn this faucet on. So what's going to happen is the equilibrium, back and forth arrows, equilibrium is going to shift to the right because you added something onto the left. So as this shifts to the right, you're going to make more of this stuff over here. And then all the stuff over here, this hydrogen is going to be used to make more stuff over here. Okay, because all the reactants, if you add NH2, what happens is you cause more hydrogen to react, and you're going to make more NH3. Now, what just happened? We added something to this side, and all the equilibrium shifted to the right. We made more stuff over here. We also made more heat in the process. Okay? Just like the same concept as if you add water to this side of the bathtub, it moves to the right. All right? Now let's say we add H2. We add more H2 into this reaction. Same thing happens. It's just like turning on this faucet. Everything's going to shift this way. So your result will be you'll add more NH3. Your N2 will begin to be used up. So everything will be shifted this way. You'll make more NH3 and you'll make more heat. Because you've shifted everything to the right. Just like if you opened up the faucet here, the water would go this way. Okay? Now, we talked about a plug. If we pull a plug, then the opposite will happen. What will happen? If we pull this plug down here, the water in the bathtub will begin to drain out. Everything from this side will begin to head towards the drain. So everything will shift in this direction. What will happen is the NH3 will get used up. It will decompose. Whoops, decompose. And then you will get more N2 and more H2. So if you pull the plug, if you remove one of these H's, the reaction will shift this way. Okay, let me show you that again. Get rid of all this scribble. If you remove some N2, it's the same thing as putting a hole in the bathtub, pulling the plug. Now all water begins to rush out this way. The chemical reaction begins to go to the left now. You're decomposing it. You're decomposing the NH3, and it's changing back into H2 and N2. So then you'll add more H2. You'll have more H2 made. This will decrease. Okay? And of course, you're in order to do that, if you wanted to make it go to the left, you would lose some heat too. Now, let's look at the other side. Same concept, people. Same concept. If you turn this faucet on, and let's say you're going to add some more NH3 right there. You're going to add some more NH3 into this tub. And guess what's going to happen? It's going to go that way. It's going to decompose faster. And you're actually going to end up with more N2 and more hydrogen. Okay? Let's say I add some heat to the reaction. If I add some heat to the reaction, then the same thing is going to happen. I'm going to decompose the NH3, and you're going to get more H2 and more N2. Everything's going to flow this way. Everything's going to flow this way. Why? Because I turned the faucet on. I turned the faucet on. The water flows this way. The reaction flows this way. You guys rewind this video several times if you don't understand what I said. Now, what if I take a hammer and I make a crack, or I put a plug there and I make a hole? Well, then the water will start rushing this way. Okay, so if I remove some NH3, or if I put some ice on the reaction and I make it colder, I remove some heat, then what will happen is everything will flow this way. Okay, you'll decrease the amount of N2, you'll decrease the amount of H2, and you'll make more of this. Because everything's flowing to the right. Everything's flowing to the right. So all this side will decrease, this side will increase. Okay, so that's how you think of Lechatliers' principle. You either go right or you go left. That's it. Okay, you go right or you go left. If I add over here, it all goes that way. If I remove over here, it all goes this way. On this side, If I add on this side, everything shifts that way. If I remove from this side, everything shifts that way. Okay? So it's opposite. Opposite. That is Lechatliers' principle. We're going to do a practice problem on the next segment here.